Welcome to NANOG's Internet Innovators, a series that allows you to learn more about some of the brightest and boldest tech minds of our time. Join us as we look to the past, present, and future of the Internet and talk to the innovators who are actually there. Every month, we will be interviewing Internet innovators who revolutionize the Internet as we know it. Watch as we host conversations with those that are building the Internet of tomorrow.
Good afternoon, Radia. How are you doing today?
Oh, fine. Yes.
Good.
Having a great time at NANOG.
Thanks. I'm glad you're a part of it. We're so excited. Your keynote presentation was amazing.
So at this time, I would like to welcome to the stage Radia Perlman. She's going to be delivering our keynote, Do the Wrong Thing. Welcome, Radia.
I especially love the story that you told about, are you solving the right problem? Can you share that story again?
Yes. So in my book, I like to illustrate technical points with real-world examples. So I have these little boxes that I explain things. So, an example is that the wine glass clicking protocol, which I'm trying to explain scalability, where it's fine if you have like 4 people, but if you have 12 people and everyone has to click everyone else's glasses, it really doesn't make any sense. But the one story that is absolutely everybody's favorite and is 100% true is that when my son was about 3, he ran up to me crying, holding up his hand, saying, my hand, my hand. So I took it and I kissed it a few times. What's the matter, honey? Did you hurt it? And he said, no, I got pee on it.
It's funny having children. It's just such an amazing thing that you learn about yourself when you have kids. So what have you learned having children?
Right. Well, I was one of the world's experts on bringing up kids until I had kids.
Okay, very good.
So my first kid was my daughter, who was just this incredible daredevil. And if you took your eyes off her for a second, you'd be visiting the emergency room because she'd be doing some crazy thing. And I was feeling secretly superior to the parents of shy kids because I knew they messed them up somehow. But then 3 years later, I was rewarded with the wimpiest kid on the planet, which was my son. He never went on swings or slides. He considered them too scary. He liked to go to playgrounds, but just to sit next to me and watch the other children play, which kind of broke my heart. Anyway, when she was 12 and he was 9, I was giving her the lecture about drugs, and I didn't realize he was listening, but it was fine. And I was telling her, I know you'll be really curious, but you're buying it from criminals. You have no idea what you're getting. Even if you get the right stuff, some people's bodies react badly and you have a heart attack from cocaine, or you ruin your mind forever with LSD. Anyhow, my son looked at me with his sweet, innocent 9-year-old eyes, and he said, you don't have to worry about me, Mommy. I don't even try things that are safe.
That's fun. So speaking of children, your parents are both engineers. Did it have any impact on you? I mean, is that what drove you in this direction?
I don't really remember them talking to me much about work. My mother, would certainly help me with homework, but most of the help that she did was helping me memorize history facts. So the way history was taught was meaningless names and dates, and I'm just terrible at that, but I wanted straight A's. So I spent most of my childhood memorizing these things. And then I would get 100 on the test, but 10 minutes after the test, it was completely gone. And my mother would, something would happen in the news and she'd say, oh, you were just studying that. And I would look at her totally blankly because it was gone. And I'm sort of very good at getting rid of stuff from my brain because I have a tiny memory. And if I have to remember any extraneous stuff, I have to forget something important like my name.
Interesting.
And actually, that's probably why I'm good at what I do. People have different skills. Mm-hmm. So some people got, so my superpower in a way is a very tiny memory. So other people could remember what the teacher wanted them to say and repeat it on a test. And I'd have to be able to derive everything from basic principles. So I'd have to really understand it very deeply.
Interesting. Is that what contributed to your path now in sciences?
Well, yeah, so when I want to solve a problem, I have to get rid of all of the irrelevant details. You know, what color is the box? It doesn't matter. You know, get to the heart of the concept. You know, which items in the packet happen first. It doesn't matter. And once you get to the conceptual heart of it, you come up with a solution that you look at it and you say, yeah, well, that's not very impressive. Any 11-year-old could have done that. But, you know, so I say that, like, the things that I have designed for the internet would have been designed anyway if I weren't there. But I like to believe, and there's probably evidence for it, that if somebody else had designed it, it would have been much more complicated, wouldn't have worked in all the cases and stuff. Yeah.
Interesting. So since we were kind of breaching that subject, spanning tree, how did it get started? How did you get involved in it?
Right. Well, that was just something my manager asked me to do, and it was a kludge because there was Ethernet, and people, and it arrived with great fanfare, and people were all excited about Ethernet. If they had called it Etherlink, it would have been much better. It was just a single link that only could hold a few hundred nodes within a single building. But people thought, oh, this is now how we're going to do networking. So people built applications. Their network stack just assumed they were talking on a single Ethernet link. And I did try to argue with them, saying, no, you still need layer 3. And they said, oh, you're just upset because your stuff is all obsolete, because I was doing layer 3. And I said, but you may want to talk from one Ethernet to another. And they said, our customers would never want to do that. So I was kind of in a bad mood about the whole thing. And the people who were doing this were real heroes in the company because they were doing good applications. But it would have been just as good had they done it correctly, which is to put it in layer 3. So years later, I was kind of in a bad mood when my manager said, Radia, we need to design a magic box that will sit between 2 Ethernets and let somebody on one talk to somebody on the other, which is, of course, what my career had been. But it requires the end nodes to put the right kind of envelope in. So this was, they already had the concept of, well, just have this box that listens promiscuously, stores up all the packets, and then when the ether is free on another port, or if you get the token ring, whatever it is, then you can forward onto the other ports. But that doesn't work if there's loops. The Ethernet header was not designed to be something that you forward, like IP. It was intended only to be a single link. And in particular, there's no hop count. So all these switches or bridges, whatever you want to call them, or routers, have forwarding tables that tell them which way to go. If the topology changes, it takes a while for it to settle. And during that time, the forwarding tables can be inconsistent, so packets can wander around. So it's important to get rid of those eventually, so that's why they have a hop count. With forwarding Ethernet packets, it's even worse, because a bridge that has like 6 ports, if you receive 1 copy of the packet, you'll make 5 copies for the other ports. So not only do you have single packets wandering around, but you're exploding the number of copies of them. So so anyhow, he asked me, he challenged me to come up with something that you just plug it together with no rules whatsoever, and no configuration, and that it should settle into a loop-free subset of the topology for forwarding the data. And that allows you to have like redundancy, so if things go down and stuff. And yeah, he thought it was going to be hard. He also told me to make it scale as a constant, so the amount of memory should not grow with the number of bridges and links, which is just right. It's just crazy, nothing is like that. He just threw that in to be funny. But that night I realized, oh, it's trivial. And furthermore, it scales as a constant, because to run this algorithm, all you need to do is remember the best spanning tree message you've heard recently on each of your ports. If you are receiving data, you say, is this a spanning tree message? If it is, you compare the one you just got with the one that you stored, and there's a trivial comparison to see which one is better, and whichever one is better, you store that and throw the other one away. And since a spanning tree message was about 50 bytes, if you have 5 ports, it takes 250 bytes to run the algorithm. So this was really cool, but it still seemed like a kludge. The correct solution was to have the end nodes do layer 3 and have a true routing protocol that does optimal paths and has a hop count and stuff. But, you know, it was fun. It's sort of remarkable that that's what I'm mostly known for. I think that
What do you think that you should be known for?
Oh, well, I think, you know, the contributions for real routing algorithms. So in particular, ISIS, or link state routing. So the first contribution, the first major one, was I did not do the very first link state protocol. It was one done in the ARPANET. So when I became in charge of designing layer 3 for digital, my managers, I said, I like the ARPANET algorithm. I would like to put that in. And he said, well, I've never been convinced it's stable. If you can prove to me it's stable. So I'm always much better with counterexamples than I am with proofs. And so I looked at it and I realized, oh my gosh, it isn't stable. So indeed, one of the routers kind of corrupting what it's sending could cause the network to be down forever. And so that's what my first paper was with a PC, it gets into bad states all the time, and so you reboot it. You can't reboot a network, especially because the way that you manage a network is sending messages on the same broken network. And, you know, if the network is broken, you can't do that. So, yeah, my first paper was saying this has this problem that the routing messages, if, you know, if a certain bad thing happens, one node going bad could cause the entire network to never recover. This is, so that's not good. Networks have to be what I call self-stabilizing, meaning that once you get rid of the node that's sick, it should return to proper operation without people needing to reboot everything. And this is how to design the algorithm to be self-stabilizing. So this whole, you know, super robust stuff, you know, networks were no longer just a researchy thing. They had to actually work, and they had to work much better than we're used to most things working. So that was kind of my first contribution. You know, I did other things to make it more scalable, but another thing was I hate technology.
That seems kind of odd, considering what you do for a living.
Right. So I design things for people like me. Which is you just plug it together and it works. So, you know, if you're a doctor in a hospital, you shouldn't have to know about IP addresses. You should know how to like cut people up and fix them. You know, in the beginning, it was all researchers working with the network, and configuration was fun and educational, but when it goes to real people. So, yeah, an example. Oh, so when I did the bridge, the spanning tree bridges, people said to me, hey, some of our customers don't like it because it's too boring. You just plug it together and it just works. So after that, you know, I said, fine, if they want knobs, I'll put in knobs and they can play with the knobs, but you don't have to touch them. It'll just work. And if you do touch them, any setting will still work. So parameters in general, all these things that you have to configure, you should have as few of them as possible. And if you do set parameters, you should make sure that you can only set it within a legal value. So if the legal values are between 20 and 30, and someone tries to set it to 471, just say, no, that's an illegal value. But there are sometimes you are configured with a legal value, I'm configured with a legal value, but we won't interwork. And an example of this is something that I was never able to explain to my otherwise bright college-age son, which is that there's no such thing as a reliable "I am dead now" message. So you have to periodically call your mother. And then there's an opportunity for a parameter mismatch, which is how often you call and how long she waits before panicking and calling the police. So in my protocol, in the hello message where you try to figure out who your neighbors are, I say, hi, I'm Radia. I send hellos every 30 seconds. What you do is you say, oh, okay, well, I should expect to hear from her every 30 seconds. I'll multiply that by 3 in case messages get lost, maybe at a second or two. And that's what that was for. And it's kind of interesting when OSPF sort of basically copied ISIS, they noticed the hello timer in there, but they sort of didn't quite get what it was for. So in OSPF, although I say, hi, I send hellos every 30 seconds, what the spec says is what you're supposed to do is compare it with your own configured hello message, hello timer, and if they're not identical, you'll refuse to talk, which is sort of very brittle, sort of no good reason to do that. They said it was simpler, but anyway.
It seems like when you're talking about your work, it seems like the driving force is simplicity. And 2, there's a certain elegance to that simplicity. And I guess with 3 is that it should just work.
Yeah.
So talk about that philosophy a little bit more in how you approach design and solving problems.
Right. So it's not just that you shouldn't have to configure things or understand things. It should just work. But it's also the reliability that, things have to work a lot more. I'm sort of surprised that software, if you read the 12-page end-user license thing, it basically says, I'm not claiming this does anything. If it actually does anything, we're as surprised as you are. And, and you begged us to let you use it.
And you don't own it.
Right. So, don't come suing us if it does horrible things or doesn't work or something. Whereas if you manufacture a toy that one kid out of 12 million manages to figure out how to tear a piece off and whatever, and they swallow it, you'll be sued into oblivion. Yeah. But somehow all of the technology stuff that we use is so fragile and so hard to use.
And so many disclaimers, just as you mentioned.
Yeah.
So how has that simplicity in that approach, how do you think that it's kind of, moved the internet forward? Because in some ways, when you have something that just works, like you plug it in and it does it, it pushes it toward commercialization. If it requires so many fiddling and special knowledge, you're limiting how it can be deployed and how it can be used. So how do you think that simplicity helped push the internet forward?
Well, things are much more robust if it's a really simple general purpose solution rather than somebody sort of seeing a case and getting all excited, writing some code and it doesn't work in all the cases you start and you wind up with this incredibly complicated thing, which doesn't quite work. So you add kind of more shims and this and that. So I think really the internet as it is and all of our computers and stuff are barely usable as they are, but if it were not, if you take out that stuff and made it even more complicated, things would be even less usable.
Interesting. Interesting. You mentioned earlier that you're kind of a aversion to technology. Can you expound on that a little bit?
Okay, well, I'll give a story. So we have our phone depends on the internet. So every week or so it doesn't work. And there's a voice-activated fix, which is I say, Charlie, can you reboot the router? And I wasn't quite sure what he did, or I didn't really care as long as it started working. Now, we have next door neighbors that when they moved in, they were actually kind of tickled that, because they had read my books and they were going to live next door to me.
Nice.
So one day, Charlie sort of fell down some stairs and spectacular accident. He's completely better, but yeah, blood everywhere. And right, yeah, so it was very scary. So I drove him to the emergency room and they wouldn't let me in because of COVID. And they told me to go home and they would let me know what was going on and whether I could pick him up. So I got home and the phone wasn't working. So the voice activation thing wasn't going to work. So I knocked on our next door neighbors.
Oh, didn't.
And I said, do you know how to reboot a router? And the guy said, didn't you invent those? But he saw I was so upset that he decided not to be playful. So he said, okay. So he came over and he said, where is it? And I said, I have no idea. So I just wandered around my house looking for things that looked electrical and unplugged them and plugged it back in. And
So you were focused on solving the puzzle, the problem at the time. And that's what you were just focused on.
I know how they work and all that, but I would not recognize one. Yeah.
No, I mean, I understand. I mean, you're focusing on a protocol. You're focusing on that whole transport layer of things. This is one particular problem you're trying to solve.
Right.
You're not inventing the whole box.
Right.
Yeah.
But, also like when my light bulb was burned out when I was a kid, I would tell my father, and a few days later it would be fixed. And I wasn't even curious what he did. I assumed it was dangerous or something. I don't know. So then I was at MIT, and my light bulb burned out, and I wandered around the dorm asking people, are you majoring in electrical engineering? And finally someone said, yes, why? And I said, my light bulb burned out. What do I do? They said, you're kidding, right? No. So I'm not a hands-on person, but on the other hand, it's sort of the theory of it all.
Yeah.
I mean, I was always good at classes, at sort of book learning. And I always knew that, okay, we're taking chemistry, I'll be the best student, physics. I wasn't even happy about it. I had a fantasy that some boy would do better than me at some math or science thing, and my plan was to fall in love with him and marry him. So one of the reasons this is relevant is that in high school, despite always sort of being the top student, a teacher noticed that there was a computer programming class at a nearby college, and the timing worked out that she could sign a few of us up for it. She could drive us over and wait for the class to be over and then drive us home. Teachers are just awesome that, she didn't get paid to do this. So I walk into the class and all the students were talking about how they had built ham radios when they were 7. I had no idea what a ham radio was. And then they were asking questions with fancy words like input. I had no idea what that meant. And for the first time, my brain just shut down and I got nothing out of that class because I felt like, oh, wow, I'm so many years behind, I'll never catch up, which, it makes me a great teacher because I understand kind of the sense of panic that you just have to sort of give people a bit of self-confidence, make it safe for them to say, no, I don't know what that acronym means or whatever. Yeah.
Yeah, because sometimes even in technology, you'll find there'll be conversations and they have all these acronyms for shorthand.
Yeah, right.
Yeah, and if you don't know that, the lingua, you're a total outsider.
Right.
What would you say to someone who was experienced the same thing? For example, choosing to study computer programming, or they're trying something completely new and they find themselves kind of overwhelmed by that. What would you advise them? What would you say?
Well, you have to have somebody that you feel safe asking questions. So I did actually learn how to program. And the way that I did that, I mean, at that point when I went to college, if you asked me what I was interested in, it was anything as long as it doesn't involve computers. But then, like, I was taking a physics class, and the TA said to me, I need a programmer for a project. Would you like to be my programmer? And I said, I don't know how to program. He said, yes, exactly. That's why I'm asking you, because I have no money to pay you.
Oh.
And if you knew how to program, you'd expect to be paid. But you're doing, you're obviously bright, because I was doing well in the class, and I'm sure you could learn. And the reason I agreed to do it, to be brutally honest, was I had a boyfriend who knew how to program. So I figured he could help me. And it was fun. Programming was great. I just had to not start out by believing I couldn't do it.
Nice.
Yeah.
Nice. And how that belief fuel you? You just said to come into approaching it not believing that you can't do it.
Right. Well, I felt safe because I knew I could always ask questions. So that's something else that I'm passionate about these days is corporate culture.
Interesting.
So like I have a whole bunch of advice there, but one of them,
I'd love to hear it.
well, one of them is that it has to be safe to ask questions. Now, how can it not be safe to ask questions? Well, in one group at one company that I was in, the culture was sort of dominated by these very aggressive, pompous people that everyone assumed were geniuses. Mm-hmm. And frankly, I've never met anyone that acted that way that actually was good technically. But at any rate, if you asked a question, especially in public, one of these people would say, if you don't know that already, you don't belong in this group, if you can imagine. So if somebody asks me a question that doesn't everybody know it, like what's a public key? I don't say, you don't know that already? I say, oh, it is the coolest thing ever. And I can't believe that I have the privilege to be the first person to introduce you to it. But there's sort of another side to it that once you get to be kind of senior, you start thinking, oh, I'm supposed to know everything. And nobody does. And if you think you do, you're really dangerous and you should retire. But if you want to be a true role model, you should be the first person that's complete, that you want to show how open and relaxed you are, that you don't know everything, and you should be the first person to ask naive questions about things, to show you're intellectually curious, that you can learn from those around you, and that you don't know everything.
Yeah. So you mentioned being able to ask questions is important.
Yeah.
What about having room to fail in projects that you're working on? Do you think that's important?
Well, that's the current thing that all the companies say, that if you never fail, you're not taking enough risks. We like failure. I don't believe them.
Okay. Expound. What do you think?
Well, no, I mean, I think it's true that you have to be able to fail, but I don't believe that companies really are happy with you, that, oh, good for you, you failed on that one. That means that you are taking enough risks.
So they're saying it, but they're not really meaning it.
Well, I don't know whether they are or not, but I'm a little skeptical. I think they'd rather that you succeeded at everything.
Did you find from one corporate culture to the other, could you actually sense the difference, whether you're working for company X or company A? Were there cultures that you kind of were drawn to, that you found comfortable with in your working career?
Absolutely. But I also think that, one of the things I'm trying to do is to get people, especially managers, to be conscious of this sort of thing. It's not like, oh, I hired the wrong people. I think it's a software problem and not a hardware problem. So if you reward the bullying kind of behavior, people will do it more and more. But if you are sort of educated to look for it and take people aside But it's so easy to sort of get taken in by these people that just seem so incredibly confident and stuff. They seem like, real geniuses, and they're not. But yeah, I think that if companies can be more aware of this and try to, also the whole concept of diversity isn't necessarily, different skin colors and body shapes. It's like the type of people that, you don't want everyone like me where I can't turn on a light switch. But you also don't want everybody that just sort of wants to sit there and write code. So sometimes people ask me, why are there so few women? And again, there's probably men that also don't go into the industry for the same reason, which is that they think that what you're supposed to be a good engineer is someone that repaired radios when they were little. And I certainly wasn't.
Mm-hmm.
And they also have the wrong idea of what a job is like. So, like if you're good at making something beautiful, you can be the difference between your company's product succeeding or not. If you're capable of speaking to human beings, that's a great skill that it is underrepresented. So yeah, I find the fact that I'm kind of different from most that I found an ecological niche for me. And I would like sort of more people to realize that if you're different in some sort of way, you have some sort of skill that other people don't, you can probably figure out a way to make that be useful.
So you're kind of consolidate that message in terms of encouraging people to explore things. What would you say?
Yeah. So when I actually get sad when I go to concerts and hear like magnificent string quartet or something, because I know how much it took to get to be that good. Mm. And even the best string quartet in the world has to constantly be doing fundraising. Whereas in the computer industry, you just have to be confident and they throw money at you. So, if people kind of realize that it's a big industry and the things you are good at will be useful within the industry. And then also you have to sort of convince hiring managers to not look for candidates that remind them of a younger version of themselves, but to realize that they should have a team that has different types of skills that can leverage each other's skills. If there's one guy that just would rather die than give a talk, fine, let him do the things he's good at. And somebody else that's, really good at writing stuff, let them do that. Yeah.
Interesting. So just exploring what's the good fit and giving people room to be able to discover who they are and be who they are in the process.
Right. And instead of, telling a person, hey, you're really not good at this, so like taking, I'm very bad at sports analogies. Tom Brady, I think is right. And telling him, you're a lousy piano player. So, forget all of this football stuff. We really need to concentrate on your playing piano. Yeah.
Yeah, very misplaced on that.
Right. Yeah. So you look for people's strengths and say, how can we leverage those strengths and the things that they hate doing or that they're really bad at? You can help them if they want to get better at that. But, ideally, you use what they're good at.
What is it that you would like to be known for? I mean, you've written some books. What would you distill it in? What would you like people to remember Radia Perlman most about?
That's a difficult question. I would like that people, felt that I inspired them in a way that it made them feel comfortable and confident, that they learned to enjoy things, that you have to have a sense of humor about stuff, that they should help each other rather than, trying to elbow their way. Yeah, if I could make the industry a better place in both ways, in terms of sort of making it a better, more healthy culture to work in, but also to make the products kinds of things that people just don't have to spend hours and hours reading manuals and stuff in order to make it work.
Found. If you could go back in time and talk to a young, let's say, 12-year-old Radia Perlman, what would you tell her?
Yeah, I'm not sure I can think of going back that far. Definitely.
You pick an age that you could go back and.
Well, definitely like going to the computer class in high school. It's like, come on, why do you think you wouldn't be able to do this? You've been able to do everything else. Yeah, so don't be fooled by that sort of stuff. The politics of various standards bodies and stuff like that, it's a really tough industry, and it's sort of surprising that I didn't completely quit a long time ago. And sometimes I think that if I had fought more, I don't know, but I tend to give up. So I've had some really good ideas that, should have also changed the industry, but because of sort of not invented here or whatever, people tried to kill it, and so I just gave up. And that's sort of too bad, because sort of worse things wound up sort of filling the void.
So if you had pushed for those things to happen, if you'd had it within you to do it, how do you think things would be different now?
Well, just certain things. There was this thing called Trill, whatever that is, which, was probably a really good idea. It sort of made spanning tree bridging it in a very upgradable kind of way. Oh yeah, that's another thing, that it's easy to say, oh, let's throw everything away and let's just do it differently. But the ideal kind of thing is something that you can take a network and one by one upgrade the components, and each time you upgrade one, it works a little bit better. But the new stuff operates with the old stuff. And so this would have made a spanning tree Ethernet. The more things you updated with Trill devices, the more the more robust, the better paths you'd get and things like that. But yeah, there were just some people that wanted to kill it, and I just can't deal with that.
What is it about you that, we talked about what you'd want to be remembered for. What about you that you would like people to know that they don't know? Something that you think that would be relevant or important that people don't ever ask you about?
Actually, let me go back to the what do I want to be remembered for?
Oh, yes.
So I sort of didn't remember anyone from high school, really. Even when I was in high school, I was sort of so shy, I hardly talked to anybody. But I just tend to not, I live in the moment and don't really remember people. But for some reason, somebody talked me into going to my 25th reunion. So I went there, and, all the people were saying, oh, I remember you. And I expected them to say, because you were number one in the class. But most of them said something that I just loved. And they said, I remember you because you were so kind. And this felt very odd to me, because there were some really vicious people in my class that just, would make fun of and bully people. And I would watch it. I was very good at being invisible, so people didn't hassle me. But when I would watch them do that to other people, it just ripped my heart out. And and I couldn't think of any way to do anything about it. So I felt, really bad about myself that I didn't do anything about it. So I was wondering, how can people think I was kind because I didn't do anything? But apparently I was nice to the people when the bullies weren't around or something.
And maybe it was a compensation. You saw someone bullying someone and then come back trying to be kind afterwards too, but as a soothing balm or something.
Right, right. So I was so proud. I was way more proud that people remembered me for being kind than that they remembered me for being, the best grades.
And and probably at the end of the day, that's probably a much more valuable thing. Kindness. Thank you very much. This was wonderful. I appreciate you taking the time.